Hello and welcome to today's GFG problem of the day. Top k frequent elements in array. So let's quickly see what the problem has to say. Given a non-empty array nums of integers of length n, find the top k elements which have the highest frequency in the array. If two numbers have same frequencies, then the larger number should be given more preference. Okay. So let's quickly see an example. So yeah. So let's take this example. 1, 1, 1, 2, 3. Right. So, what does the problem say? The maximum frequency of the elements, of the k elements we should return. So, here if we consider the frequency of 1, it is 3. Frequency of 2 is 2. And frequency of 3 is 1. So, whichever is the top frequency, whichever is the element which has top frequency, we have to return them. So, for example, you have to return k such elements, k top frequency elements. If k equal to 2, then we have to return this particular 1 and 2. We have to return 1 and 2. If you can see in the output, it is 1 and 2. Also, the problem says one more thing, that the larger number should be given more preference. So let's say for an example, if we take an example here, right? 6, 1, 2, 3, 4, 5 and 6. So here if we consider the frequency of 6, it is 2. 1, it is 1. 2, it is 1. 3, 1, 4, 1, 5, 1. Okay. And what is the k? Let's say k is 6. You have to return elements with 6 top frequencies, right? 6 elements with top frequencies. Okay. You have to return here. How many numbers are there? There are 7 numbers, right? Okay. So what does this say? So first, it is pretty simple. 6 will be the topmost element. Then what it says is, if there are two elements with same frequency, then the larger number has to be preferred, right? We have same frequencies here, 1 and 5, and rest elements as well. So we have the larger element should be outputted, okay, should be preferred. So here it will come 5. Similarly, then 4 will come, 3 will come, 2 will come, and 1 will come. So if there are two elements with same frequency, we have to give preference to the larger number. Okay. So I hope this is a problem. I hope you must have understood the problem. Let's quickly go through the code, right? Let's quickly go through the code now. So what we'll do first, the time complexity, also the given time complexity is n log n, and the space complexity is O of n, right? So first what we can do is, we can iterate to the array, right? We can iterate to the array 1, 1, 1, 2, 2, right? And simply we can take a map and put these elements. So what it will be, 1, 3, 2, comma 2. This is the map, right? Now what we want to do is, we want to return, right? It could have been the case, right? For example, if uh, 2 would have been first, right? So it would be like this. But what we have to return? We have to return the elements in their maximum frequencies, right? In the order of the maximum frequencies. So we have to return like that. So how to make sure that we return the elements, right, according to their maximum frequencies? Okay, so there's one such concept as we call heap, right? Heap. There are two types of heap. One is min heap and one is max heap, right? So let's consider what max heap is. What max heap does is, it creates a tree-like structure, right, which has maximum elements stored. Which has, for example, right? For example, if we consider this, for example, let's consider this case 4, 5, 6, right? If there's a 4, 5, 6 element, and if we insert into max heap, what will the order be? 6 will be on the top, 4 and 5. It will be like this. 5 will be stored on the right hand side and 4 will be stored on the left hand side. So whenever we ask to return the element, whenever we ask to max it to pop out an element, it will pop out the largest one. Okay, it will pop out the largest one. So we have to do the same thing. For example, if we consider, right, if we consider, yes, so it will return the the top element, right? So what are we going to do here now? What are we going to do here now? For example, let's take an example of this example. Okay, uh, 6, 1, 2, 3, 4, 5, and 6. Right? Let's take an example of this. Now, how we want to store this one, right? This and also how will the map will store the elements 6, 2, 1, 1, 2, 1, 3, 4, 5, 1, right? But what we want is after 6 it should return 5, right? After 6 it should return 5. So what we'll do, we'll implement our uh, the max heap, right? The max heap in such a way, okay, that um, so for example, right, we'll store according to the max heap according to the frequencies, the top frequencies, right? We will store according to top frequencies. So how we can store 6 comma 2, it will be to top. We'll compare this basically the frequency, and what the next element will come 5 comma 1, the highest one, right? 5 and then 4 comma 1, right? 3 comma 1, okay. Similarly, yeah, so it will store the elements. It will in the priority queue, right? In the max heap it will store the elements according to the top frequencies, okay. So whenever we ask for the such element, the greatest element, the element with the greatest with the top frequency, then it will return uh, 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 the top element, basically the element with top frequency, okay. So let's quickly look at the code. Okay, let's quickly look at the code to understand. I have already implemented the code here. So if you see, right, first what we are doing is we are creating a map, right? We are creating a map, and uh, here the map will store the frequency, right? The frequency of the elements. Whatever is the element, get or default. It what it does is it gets the element n if it is present, right? And then we are adding the frequency, the value of n or the frequency of n, and then we are adding the one to it. If the n element is not found, then the map will return 0, and it will add 1 as a value, as a frequency. Then once it is done, right, once we have the map, then what we need to do, as we want to implement the max heap, right, we want to store the elements in the max heap, we use priority queue. Priority queue is a data structure which lets us implement the heap data structure, okay. So what we are doing simply here, this is important, we are creating a priority queue of directly the map entries only, okay. And then what we are doing is we want to store the elements according to the top frequency, right? So what we are doing here is b dot get value, b dot get value. So what is b here? It is map entry, right? And value is the frequency of that element, right? So we're going to store the top frequency. For example, if such is the case, right? Two. Let's say 2 comma 2 and 3 comma sorry, not 2 comma 2 and 1 comma 3, right? So let's say if these two elements come, right, if these two elements come, right, 2 and right, 2 comma 2 and 1 comma 3, these are the map entries. Now what we have to do, what we are doing here is we are comparing the values, right? We are comparing the values and we are storing accordingly. So here what we are doing, p dot get value, right? P dot get value, p dot get value, right, minus a dot get value. So what here it is doing, it will store this particular pair first according to the frequency. But how it will store? How it will store 1 comma 3, sorry, 1 comma 3 and then 2 comma 2. It will store like this. Okay. So yes, so this will take care of the frequency, right? It will store in this way 1 comma 3 and 2 comma 2. Now the other part of the problem is if there are two elements, right, with same frequency. you have to give preference to the larger element. So for example, if the case is 1 comma 1, right? This is an element and 1 is a frequency, and we have 5 comma 1, right? We have those two elements, 1 comma 1 and 5 comma 1. So we have to give preference to the top element, right? We have to give preference to the larger element, basically the larger element. So what we are checking here is, if the frequency of the two elements is same, then sort sort or put the larger element according to the six. What we are doing is key. We are checking five, whatever. So this particular statement will store the larger element. Okay, and then simply what we are doing here is, we have declared the priority queue here, right? And then we are iterating to the map, and we are putting the entry in the map in the priority queue. And then simply what we are doing, we want k top such elements, right? K top elements, right? K elements of top frequency. So we are iterating through, we are removing, right? The one by one we are removing the top with the elements with the top frequency and adding in the array. So this is the solution. Let's submit. So yes, the solution seems to be accepted, and also we are adhering to the time complexity, right? So storing and fetching elements from priority queue, it takes n log n, right? It takes n log n, and we are using extra space, right? O of n, that is a priority queue. So we are adhering to the conditions. So thanks for watching. Kindly like the video and subscribe to my channel. Thank you.